Let's jump right into this explainer. We're tackling three completely different hazards today, and honestly, every single one of them is capable of destroying a vessel if they slip by undetected. We're talking hydrogen sulfide, combustible gas, and of course, fire. Each one requires a totally different kind of sensor. The Fire and Gas Detection System's job, or FGS, sounds simple enough on paper, right? But it is incredibly hard to execute. It has to sense every single one of these invisible threats in every space they're likely to pop up and do it way faster than they can spread.
Because think about it, how do you fight a threat you can't even see or smell? To really grasp how the FGS works, we have to recognize that our worst enemies out here are usually invisible. We need a system that acts as our eyes, our ears, and yeah, sometimes our nose, sensing these dangers long before things spiral out of control. Now, the FGS doesn't just sit there in a vacuum. It acts as the primary sensory input for the emergency shutdown system, feeding alarms straight into it to trigger those exact scoped shutdown responses we talked about in our previous analysis.
So here's how we're going to map out the ship's high-tech defense network today. First, we'll look at sensing invisible threats. Then, the analog addressable advantage. After that, gas limits and toxic thresholds, followed by high-risk vessel zones, and finally, trusting the sensor.
All right, let's kick things off with Section 1, Sensing Those Invisible Threats. Our system is on a constant 24/7 hunt for three very distinct signatures. First up is hydrogen sulfide, or H2S, which is a highly toxic gas you'll commonly find lurking around hydrocarbon-bearing formations. Then we have our combustible gas sensors, looking for explosive atmospheres, and obviously smoke and fire detectors. By keeping a constant watch for these three specific hazards, the system can instantly ping the ESD system if something goes sideways. This early location-specific detection, that is exactly what buys responders and automated safety systems the precious seconds they need to actually do their jobs. Moving right along to Section 2, let's talk about the analog addressable advantage. Now, this right here isn't just some minor technical spec to gloss over. It is literally the ultimate tactical advantage for emergency responders. A lot of people miss this, but analog addressable is the difference between a responder knowing exactly which detector out of dozens is going off versus just knowing an alarm is sounding somewhere in this general area. This system gives you precise sensor-level data. You know exactly where the threat is, and you can see what the reading trend looks like in real time. It's so much more than just a basic on-off switch.
Think of it like this. It's like having a modern smart home smoke detector that tells your phone exactly which room in your house is burning, compared to one of those cheap old-school shared circuits that just rings a really loud bell somewhere down the hallway. When you're out on a massive 6th or 7th generation drill ship, knowing immediately that one specific sensor on the port side of the shaker room is spiking, that gives your emergency teams a massive head start. That level of precision directly speeds up response times when seconds literally mean the difference between life and death.
Okay, Section 3, Gas Limits and Toxic Thresholds. Let's get into the math.
Combustible gas sensors are basically measuring just how close the local atmosphere is to becoming flammable, and we express this as a percentage of its lower explosive limit, or LEL. The formula is super straightforward. It's the actual gas concentration divided by the lower explosive limit concentration, multiplied by 100. This invisible gauge is just constantly running in the background, checking the air to see how dangerously close it's getting to that threshold where a single random spark could just ignite the air itself. But here is the crucial takeaway. These LEL alarms are intentionally set way below 100%. Usually, they're sitting right in that 10 to 20% range. Why so low? Specifically, to buy you maximum warning time before a truly flammable atmosphere can even form. The goal is definitely not to alert you when the air is already explosive. That's too late. The goal is to alert you while you still have time to kill ignition sources, ramp up the ventilation, or just get everyone out of the area entirely. Let's shift gears to Section 4, covering our high-risk vessel zones.
You see, these sensors aren't just scattered randomly around the rig. They are highly strategic. They are placed exactly where hydrocarbon gas, or H2S, is most likely to break out. We're talking heavy monitoring on the drill floor, the mud pits, the shaker room, and the deck control room, or DCR, air intake. By putting dedicated H2S and LEL sensors right at the mud pits and shaker room, you're targeting the absolute highest probability release points head-on. And at the same time, keeping a close eye on the DCR air intake, make sure that if gas does manage to escape, that contaminated air isn't accidentally getting sucked right into occupied control spaces.
You might remember our earlier explainer on the mud system. Well, the drilling fluid coming back up the annulus is carrying rock cuttings, sure, but it can also be dragging entrained gas straight up from the formation. The mud pits and the shale shakers are the very first places that gas gets liberated at the surface. So if there's a failure of the shale shaker fume hood, or if someone bypasses it entirely, that directly and immediately spikes the exact gas exposure risk that these specific FGS sensors are standing by to catch. It's a great example of how the mud system and the gas detection system are fundamentally, practically linked. And that brings us to our final part, Section 5, trusting the sensor. I really want you to think about this scenario because H2S, commonly known as sour gas out in the field, is incredibly toxic even at minuscule concentrations. Imagine you're standing on the drill floor. The H2S sensor on that analog addressable network we just talked about starts climbing. The alarm is blaring. But you take a breath and you smell absolutely nothing unusual. What do? Do you just assume the machine is glitching and it's a false alarm? The absolute, non-negotiable answer is you always trust the sensor over your own human perception. H2S is incredibly deceptive. At very low nuisance levels, yeah, it smells terrible, like rotten eggs. But here's the terrifying part. At higher, lethal concentrations, it literally deadens your olfactory nerves. It turns off your sense of smell. If the concentration spikes fast enough, you might never smell a thing before it knocks you unconscious. You literally cannot ever rely on your nose to judge if it's there.
And honestly, this is exactly why we engineer such elaborate, redundant, and highly precise detection networks in the first place. Our human senses are way too easily fooled, but properly calibrated analog addressable sensors are not. So, as we wrap up this explainer, I want you to ask yourself, in a life-or-this environment filled with invisible hazards, are you ready to completely surrender your natural instincts to the precision of the sensors keeping you alive? Definitely keep that in mind the next time you see that alarm panel light up. Thanks so much for joining me for this explainer, and I will catch you on the next one.